Hello everyone, welcome to our first review video. We will review first topic, Module 1, Heat Transfer. So in this module, we have these intended learning outcomes, our ILOs. Okay, must be able to describe how heat is transferred by conduction, convection, and radiation. And then identify real-life examples of these methods and solve problems and methods of heat transfer. Okay, so in this module we have this topic. Okay, we have this example in real-life physics, and then we have a preview, temperature and heat. I believe you have discussed this in your physics subject in senior high, STEM. Okay, this is the background. And then we have the three mechanisms of heat transfer. Each of these mechanisms is described. Okay, and then convection, radiation. Then we have examples of these problems, word problems, as examples of these mechanisms. So let us review this topic. Okay, again, we discuss directly the mechanisms of heat transfer because we assume that you already discussed this topic, temperature and heat, in your senior high school. But let us discuss a little bit about this one to clarify the difference between temperature and heat so that we can understand better the mechanisms of heat transfer. Okay. Now, temperature and heat are two different quantities. So when you say temperature, okay, this is a measure of how hot or how cold the object is. So temperature is a measure, okay, a measure of hotness or coldness. Okay, coldness of an object. So because it's a measure, it's a quantitative measure, so you have temperature described in terms of numbers and then the units. Okay, and you are familiar with the Celsius, the Fahrenheit, and the Kelvin temperature scales. So temperature is a measure, it's a quantity that describes hotness or coldness of a body, while heat, okay, heat on the other hand, this is a form of energy. Okay, heat is energy transferred. Okay, when you have a difference in temperature, then there is energy transfer. So heat is energy transferred due to a difference in temperature. Okay, temperature change. So the body does not contain heat, but heat is the energy transferred when there is temperature difference. Okay, for example, so you have your object. Okay, suppose your object, the temperature of your object is, let's say, pH, and then your object is in a surrounding with temperature TL. Okay, so TH is higher temperature, L is lower temperature. In this case, your object will transfer heat, okay, to the surrounding. We'll denote heat as Q, temperature as T. So whenever there's difference in temperature, there is energy transfer, and that energy transfer is in the form of heat. And You also familiar with this equation, Q equals mc delta T, or you can have the m as the mass of the object or substance, C is the specific heat capacity, and then the temperature difference. I don't know what you used. Did you use T2 minus T1? Or sometimes you can also use temperature difference. You can also use TF as final temperature minus TI initial temperature. So take note that this temperature, this final and this initial temperature, is the temperature of the object. Okay. So this means that from what you have learned in your high school physics, that for example, when you have an object, initially its temperature is T1. Okay. So when the object changes its temperature, okay, it's either the object will absorb heat or it will release heat. Okay, when the object absorbs heat, its temperature increases. Okay, so when the object absorbs heat. When the object liberates or releases heat, the temperature of the object will decrease. Okay, so the object can absorb or can release heat, and then accordingly its temperature will either increase or decrease. The amount of heat required to change the temperature of the object is this. This is the amount of heat required to change the temperature of the object. So when the object absorbs heat, its temperature increases, so the final temperature T2 will be greater than T1. Then from this equation, you will get positive Q. But when the object releases heat, okay, the object releases heat, decreases its temperature, so in this case the final temperature T2 is less than T1. So liberated heat is negative. So that's why you get negative Q from this equation. Okay, this is how the object increases or decreases its temperature by absorbing or releasing heat. So how does an object absorb or how does the object release heat? So ito yung topic natin, the mechanisms of heat transfer. These are the methods. Okay, this is how objects absorb or liberate heat. So we have three. Okay, we have conduction, and then we have convection, and the third one we have radiation. Now sa conduction, dapat yung tandaan dito is that this is heat transfer by contact. Okay, contact. And then in conduction, okay, sa conduction, usually metal rods or good heat conductors. Usually metals are good heat conductors. You can also use glass or plastic or paper. Okay, so as long as the medium, in this case the conductor, is in contact with the object with high temperature or low temperature, then conduction can occur. So here it is describe how conduction transfers heat. So sa conduction, Okay, sa conduction, tandaan natin na dapat may contact. For example, you have a metal rod because metal rod is a good heat conductor. So for example, yung source of heat mo is nandito. For example, you have a candle. Okay, nandiyan na lang na candle ito. Okay, so the candle is in contact with this side. So this becomes now the higher temperature region. This here is the lower temperature region. Okay, heat is transferred. Okay, again, you have to take note of this. Heat is transferred from region of high to region of low temperature. So it's always from high to low temperature. It's spontaneous direction of heat flow. We'll discuss the reason of this later sa topic natin sa second law of thermodynamics. So we can see that heat is transferred from region of high to low temperature. So this must be the direction of our heat flow. So from the discussion, you learn that it's because of the atoms and molecules inside the metal, specifically the electrons that will carry the energy, absorbs the energy and then transfer it to another electron or to the atoms, and then it's like a domino effect transferred to the neighboring atoms, so that heat is transferred from this to this end. Now the amount of heat that is transferred, okay, the amount of heat that is transferred should be amount of heat transferred per given time interval. So kaya ang tawag natin dito ay heat current. Amount of flow per given time. So we have dq over dt, or you can simply write this as q over t. That's why the unit of heat current is pareho sa unit sa watts, because it's a rate of flow. Heat is in joule, time is in seconds, so 1 joule per second is 1 watt. Okay, 1 joule per second is 1 watt rate of heat flow. So saan nakadepende ang rate of heat flow sa conduction? So we have the equation H equals K, the thermal conductivity of the object, the cross-sectional area, and then the difference in temperature, TH minus TL. Okay, over the length. Anong ginamit natin sa module natin, because you might be confused with the L here. Okay, we are using TH and TC. So let's use this. Let's use TH and TC to avoid confusion, because we have L here. Okay, so let me move this. So let's change that to TC, and then this one, let's remove this, then let's change this to L. Okay, now K here is the thermal conductivity of the object, so that's different. Depende yan sa material natin. So these are the examples of thermal conductivities. For metals, you have here, you have higher values for metals. For other solids like brick, ice, styrofoam, wood, so we have here most or less than 1. So what's the meaning of these values of thermal conductivities? The greater the values of thermal conductivities means that these materials are very effective in transferring heat. So they can transfer heat faster. Well, this one, okay, less than 1, or we have here 1.6 for ice, This means that these materials transfers heat slower than metals. So if you want to prevent heat from transferring, you can use these materials. If you notice your ice box made of styrofoam, made of plastic, or can have here glass, so the thermal conductivities are smaller. Now look at wood, it's very small. That's why if you have wood, even if the other end of wood is on fire, you can feel the other end as cold. But if you use metal, siguro napansin niyo kapag yung kutsara ang gagawin yung pang stir, kahit yung kabilang dulo lang ang in contact with the higher temperature, but you will notice that yung end na hinawakan mo iinit siya because metals are very good, effective in transferring heat. So again, the greater this value, the better the conductor, the faster heat is transferred. So yun siya ang sa thermal conductivity natin, itong K. Itong A naman, okay, itong A, this is the cross-sectional area of the medium. For example, ang gamit mo na metal is ito in heat transfer. So if it is, for example, round, the cross-sectional area is this one. Okay, that's the cross-sectional area of the rod. So kapag tubular ang rod mo, for example ito yung tinutukoy niya na cross-sectional area. Okay, for this one, it's length times width. You can get the area. Pero kapag circular, the area of a circle is pi r squared. So, depende yan. So, mostly, for example, conductors, you have this circular, then the other one, we have this square. Okay, so depende yan. So, yun ang cross-sectional area. Ito namang L, the length of the conductor. For example, this one, itong length na ito. Okay, this is the span. Okay, the length which the energy heat travels. So from here until here. Okay, now this one, the difference in temperature, this is the temperature at the hotter region, this is the temperature at the colder region. This whole term, we call this the temperature gradient. Now what can we learn from this equation? The rate of heat transfer is directly proportional to K. The greater this value, the faster the heat transfer. It's also proportional to the cross-sectional area. The bigger the cross-sectional area, the faster the heat transfer. But it's inversely proportional to length. The longer the path or the length that the energy travels, the smaller the heat transfer. Why is that? Take note that this is time rate. Okay, time rate. This heat transferred per given time. The longer the length, the farther the length, the more time required for heat to be transferred. But it's directly proportional to this difference. The greater the temperature difference, the greater the amount of heat is being transferred. Okay, and I think ma-prove nyo ito. I don't know if you're aware, yung parang question, saan daw yung mas mabilis mag-ice, mag-turn into ice? Yung malamig na tubig na ilagay mo dun sa ref, or yung mainit na tubig na ilagay mo dun sa ref, or freezer? So ang sagot doon is yung mainit na tubig, mas madali siyang mag-ice. So parang counterintuitive siya, but actually ito yun. The greater the difference in temperature, the faster the heat transfer. Kaya mas mabilis magiging ice yung tubig na mas mainit kaysa mas malamig. Okay? So ito yung sa heat transfer by conduction. Other examples nito, you are familiar with yung mga coolers. Diba, gusto natin na malamig yung ating mga soft drinks, mga juice natin. Diba, yung mga cooler mostly are made of styrofoam or made of plastic. Okay. Okay. So, paano nila piniprevent ang heat transfer? So, kung lagyan mo dito ng ice, for example, ice. So, nandito yung mga drinks mo. Okay. The outside temperature, sample yung sa outside temperature, yun yung higher temperature. Dito naman sa loob na may ice, ito yung lower temperature. So, in this case, heat will be transferred from outside to inside. So, ang gusto natin, manatiling malamig itong ating drinks dito with the ice. So, kung gagamitin mo ay metal na cooler, mabilis yan mag-transfer ng heat. So, iinit agad itong ating cooler. So, kung iinit siya ulit, heat is transferred to ice to the drink. So, mag-increase ang temperature. So, iinit siya. So, ang gagamitin natin, usually is yung mga plastic or styrofoam or styrofoam. So, pansin nyo kanina, dito, ang styrofoam, napakaliit ng kaniyang thermal conductivity. So, very, very slow ang heat transfer. So, yung lamig dito sa loob ay magtatagal. Okay, so, in this case, paano naman ang ating cross-sectional area? In this case, kapag i-apply natin sa cooler, so, ang cross-sectional area natin dapat is yung total area ng surface. Okay, so pwede natin i-assume na itong temperature outside is uniform. So, dapat kunan mo ito ng area dito sa taas. Tulo tayo ulit. Okay, so may area dito, area dito. Okay, so area dun sa kabila, dito sa ilalim. Dapat i-total mo yung area na yan. And then if the thickness of the, example, itong thickness ng ating cooler is uniform, so yun ang gagamitin mo na L dito. Yung thickness niya. So isa lang naman ang thickness nito kapag uniform ang thickness. Ito lang area, dapat i-calculate mo ang total area ng surface. Kasi dito, mag-heat transfer dyan, mag-heat transfer dito, merong heat transfer dito. Okay, meron ding heat transfer dito. So, actually, 6 surfaces may heat transfer. So, yun i-consider mo na total na A. Pero ang thickness, isa lang, kasi isa lang naman ang kanilang thickness. Uniform naman ang thickness. So, isang example yan ng ating conduction. Okay. Another example is yung sa stove. For example, ito yung stove. Ano bang gamit nyo na stove? Electric, usually gasol man, di ba? So, example, ito yung burner, dito yung ating flame. Okay, ito yung flame natin sa burner natin. So, tapos meron tayong lagayan dito ng ating cookware. Yan. So, example, may tubig ka dyan. So, ito ang source of heat natin, yung ating flame sa gasol, ito yung TH. Okay, ang heat is transferred from here papunta dito. So, which is TL. But then eventually, kapag mag-absorb ng heat lagi ang ano natin, mag-absorb ng heat ang ating example ng tubig, so mag-increase ang kanyang temperature hanggang mag-boil siya. But the direction of transfer of heat is from the source to papunta dito. Okay? So, ang thickness, example, yung thickness ng kaldero, ganun ba kakapal yung kaldero na yan. So, yan, isang example yan ng ating heat transfer by conduction. Okay, next is, skip na natin ang convection kasi wala naman tayong problem solving sa conduction. Sabi ng libro natin, is beyond the scope of this book. So, it's beyond the scope of this level yung sa convection because complicated yung convection. Yan yung mga ginagamit natin kapag tayo ay nag-analyze, nag-calculate sa yung mga weather systems, climates. But if you notice, dito sa conduction, para mag-transfer ang heat, kailangan mo ng conductor. Okay? Kailangan mo ng conductor kapag mag-transfer ka ng heat. Dito naman sa convection, kailangan mo rin ng medium. Sa convection naman, kailangan merong fluid. It could be air or water. So, para may convection, dapat may fluid. Pero kapag walang fluid, example sa outer space na vacuum, hindi pwede si convection. Kasi kung sa conduction, si electrons ang mag-carry ng energy, sa convection, ang mag-carry ng energy is si fluid. Very interesting ito, especially if kapag nanonood kayo ng videos about climate change, bakit nagka-climate change, usually ma-discuss itong convection. May mga convection currents tayo. Ang ating Earth is meron siyang convection currents, may cycle tayo. Yung warm air rises, okay, convection yan siya. Okay. Yung mga storm systems natin, convection yan siya. Okay, ito kung makikita niyo, ito yung sa heater. So meron kang heater. So higher ang temperature kasi dito, napapansin niyo ito, convection current. So yung fluid dito na mas mataas ang temperature, nabumove siya upward. So ito yung nagkikarry ng energy. Dito ang lower temperature, dito ang higher temperature. So the fluid itself carries the energy. So yan ang sa convection. So take note lang kayo dito sa dalawang types ng convection. Meron tayong forced at meron tayong natural na convection. Okay, now dito tayo sa radiation. So itong radiation, ito yung pinaka-effective na mechanism of heat transfer because hindi niya kailangan ng medium. Hindi niya kailangan ng conductor, hindi niya kailangan ng fluid. Ito yung mechanism of heat transfer ng heat coming from the sun to earth. Kasi outer space is vacuum. Kaya heat, this energy is transferred by radiation. So ang ano lang niya is electromagnetic waves ang carrier ng radiation. So example, visible light, infrared, ultraviolet, microwave. So yun ang example ng radiation. Ang kailangan nyo lang tandaan dito sa radiation is itong temperature na ito, dapat ito ay naka-Kelvin. So yun ang dapat talaga tandaan ninyo sa radiation. So sa heat transfer, sa radiation, tandaan nyo lang sa equation natin na H equals A E sigma temperature to the fourth power. So pansinin nyo, temperature to the fourth power. That's how effective radiation is in transferring heat. Okay, this temperature must be in Kelvin. Kapag ang given sa problem ay Celsius, convert that to Kelvin. Itong A dito again is the cross-sectional area or the surface area. E is emissivity, so between 0 and 1. Yan lang ito, bibigay ito sa problem. And then this is a constant, Stefan Boltzmann, 5.67 times 10 to the minus 11 ba yun? 10 to the minus 8. Okay, Stefan Boltzmann constant ito siya. Okay, so anong dapat natin tandaan dito? Gas temperature should be in Kelvin. So, sa radiation, any object ay nagra-radiate. Example tayo, yung body temperature natin is 37 degrees Celsius. Okay? And then, ang room temperature is, ipagpalagay natin, 25 degrees Celsius. So, nag-i-emit tayo ng radiation. Okay, example, nag-transfer tayo ng heat by radiation Q papunta sa surroundings natin. Papansin niyo ito kapag, for example, naglalaro ka or exercise ka, intense yung exercise. Di ba mapapansin mo parang may increase in temperature. Example, nakatabi mo yung galing laro, intense na laro, di ba ma-feel mo yung init ng kanyang katawan. So, nag-i-emit yan ng energy in the form of heat. And then, usually, ang radiation, papansin nyo yung mga may lagnat, anong ginagamit nila? Yung thermal scanner. So, may mga body temperature na ito ay mataas ang lagnat niya dahil may ganitong kulay. Okay, yung mga thermal scanner, i-calibrate nila na bawat temperature is may color coding, may red, may white, may blue. So, yun, nag-i-emit tayo ng radiation actually. Any object, nag-i-emit niya ng radiation. Hindi lang natin makikita because ang iba dyan sa infrared, UV na part ng spectrum. So, hindi natin makikita. Usually, makikita natin yung red, okay, yung blue flame, for example. Okay, yun ang nakikita natin ng mga kulay sa temperature. But there are objects na nag-i-emit sila, kaya nga may mga UV na UV at saka infrared na mga scanners or UV and infrared na mga telescopes kasi yun lang na part ng spectrum ang kanilang ma-detect. Okay, so itong area, for example, ang object ay sphere. So, syempre, ang sphere, all of its surfaces are emitting energy. So, ang area na gagamitin mo kapag sphere is the area of a sphere. Ano ba ang area ng sphere? 4 pi r squared. Yata, area ng surface ng sphere. Kung ang object mo is a cube, example, ito yung object mo, cube, meron siyang temperature T. So, ang area niya is, ito no, length times width. Multiply mo yun pa into 6 times its length times width kasi 6 yan, 1, 2, 3, 4, 5, 6. Okay, yun lang ang tandaan ninyo kapag sa surface. Okay, meron din tayong equation sa radiation na equal to A E sigma, then meron ganito T minus Ts. Yung Tx naman is surroundings. For example, ang object mo, a sphere, nasa surrounding. Ang surrounding natin, meron siyang temperature Ts and then meron siyang temperature T. If the temperature of the object is higher than the temperature of the surrounding, so nag-i-emit siya ng radiation. Mag-release siya ng heat to the surrounding. But if the surrounding temperature is greater than the temperature of the object, so in this case, the object absorbs heat. Okay, in this case. Okay, yun na naman ang tandaan natin sa radiation. Dapat itong T natin should be in Kelvin. Itong area natin, take note of this is not the cross-sectional area but the surface area of the object that is emitting radiation. Okay, so meron tayong mga examples dito. I usually designed or discuss the examples as if I'm discussing it verbally. Okay, so nilagay ko dito ano itong mga given dito, itong mga length, area, higher temperature, lower temperature. So yung iba meron na silang diagram. Okay. And then dito solve natin, substitute lang ito, madali kasi ito directly substitution itong sa number 1 kasi given na yung mga quantities natin. Now, dito sa number 2, papansin niyo wala itong drawing ito na problem kaya ako ang gumawa ng sketch. So, medyo pagpasensyahan niyo na itong sketch natin. Okay? Now, ang number 2 is merong tayong composite rod. So, hindi siya parehong rod. Magkaiba, may brass, may copper. So, ang tandaan nyo lang kapag ganito ng mga problem, okay, meron tayong region of higher temperature, region of lower temperature. So the direction of heat is from high to low. Ang tandaan nyo tayo dito is that, tingnan nyo itong equation. Ito. Okay. Remember that our heat transfer depends on higher temperature from higher region, temperature from lower region. So kahit magkaiba itong materials na ito, brass and copper, the amount of heat transferred from region of high to region of low temperature ay dapat uniform, pareho. So ang heat transfer through brass, pareho lang yan sa heat transfer through copper. So pareho sila ng heat flow. Papansin niyo, pareho silang heat flow. Kaya nag-equate tayo dito. Okay? But ang tandaan nyo lang dito is itong temperature T. Ito yung junction temperature. Ito yung temperature dito. Okay? So, syempre, the heat transfers from high to low. So, itong temperature T should be lower than TH but greater than TC. And then, pansinin nyo rin ang arrangement ng ating temperature. TH minus T, T minus TC. So, tandaan nyo lang yan. Now, in this example, na-simplify natin siya because ang cross-sectional area ng mga rods natin ay pareho. Okay, pareho kasi yung cross-sectional area ng rod natin. Ito. Each segment has the same cross-sectional area. Kaya kapag i-apply natin yung rules ng mathematics, pwede natin yung makancel. Okay, kung napapansin niyo dito sa examples natin, hindi naman talaga ito very detailed na parang every step ay ginawa ko. So, I left some of the steps for you to practice. Okay. So, kung may mga steps dito na missing, kayo na ang bahala doon. This will serve as practice. So, para ma-practice ninyo, ma-review ninyo yung mathematics ninyo. Okay? Kasi ang isa sa ating ILOs, isa sa ating intended learning outcome is dapat you can solve problem on your own. Okay? So, sinadya ko talaga ito na dito sa mga examples ay hindi very complete yung solution. Some of the steps you should work out on your own. Okay? Because math na kasi ito, nadaanan nyo ng math, ang daming math na nadaanan ninyo. So, you can practice so that you can refresh your mathematical skills. Okay, for example, dito, okay, so I leave out the some of the details, and then you can work out some of the details here. Okay, so this is our first review video. So if you have questions, you can always contact me for your questions. So that's all for now. Thank you for watching.